In this video, we're going to be discussing how to solve, graph, and write simple and compound inequalities. So things to remember: if you multiply or divide by a negative number, you must reverse the inequality symbol. So for example, if we were to want to solve this inequality, in order to solve for x, we would need to divide both sides by -3. And whenever we divided by a negative, the inequality actually flips from a less than to a greater than sign to get -4. And then if you would write this in interval notation, it would be everything from -4 to infinity. Is not a bracket because it did not include -4. Now, the second thing you need to remember is the variable needs to be on the left-hand side of the inequality. That helps us to know in which direction do we need to go, to infinity or negative infinity. And last, there is such thing as no solution or all real numbers from an answer to an inequality that we will discuss later. So let's actually solve this inequality, and we're going to write the solution in interval notation. So in order to solve this inequality, I first need to get rid of the parentheses by distributing the 5 to get 5 times 2 is 10, and 5 times -x is -5x. Now, on this case, we have 6 and 10 that are on the same side. So we're going to go ahead and combine like terms since they're on the same side to get 16. And then in order to isolate the x, we are going to subtract 16 from both sides in order to get the numbers together. We'll get -5x is less than or equal to 25. And then we need to divide by -5. Now, because we divided by a -5, the less than or equal than sign, and less than or equal will now need to be a greater than or equal sign. 25 divided by -5 is -5. So if we were to graph this solution, then if this is 0, this is -5, negative infinity is to the left, positive infinity is to the right, we would have a closed circle at -5, and it is everything going to the right, all of the numbers that are greater than -5. And then to write in interval notation, we would be going from -5, it's a bracket because it does include it, in everything to infinity. Now, in this case, we're going to find something different actually happens when we get to our answer. So let's go ahead and solve this first. We will get 2x minus 3 is greater than, I got to distribute to get 3x minus 15 minus x. Now, we have a 3x and a -x on the same side, so we need to combine like terms. We will get 2x minus 3 is greater than 2x minus 15. A 3x and a -x give me 2x. Now, I need to get the x, well, I can do one of two things. I can either get the x's together or I can get the numbers together first. It does not matter. So if we were to get the x's together first, we would go ahead and subtract 2x from both sides to get rid of it. But what happens is 2x minus 2x ends up giving me a 0. They cancel, leaving me -3 is greater than -15. And so we actually have the inequality, -3 is greater than -15. There are no x's. Now, is -3 greater than -15? Yes, it is always greater. So therefore, the answer to this inequality is actually all real numbers. No matter what you plug into x, the x's end up canceling, leaving you with a statement that is always true. So in this case, you would get all real numbers. There is such a thing as if you were to get 3x minus 2 is greater than 3x plus 4, for example. If you were to subtract the 3x's, they would cancel, leaving you with -2 is greater than 4. Is -2 greater than 4? No, it is not. So the answer in this case would actually be no solution, because there is nothing you can place into the x in order to make this statement true. Okay, compound inequalities are joined together by either an and or an or. The inequality that deals with the and inequality can be written as either x is greater than -1 and at the same time it must be less than 3. Can be written as a compound inequality that x is being contained in between -1 and 3. As an interval notation, it would go from, sorry about that, it would go from -1 to 3. It is a parentheses because it does not include it. If you were to graph this, this would be 0, -1 is here, 3 is over here. You would have infinity, you would have negative infinity, and this is everything in between -1 and 3, because you want everything that is greater than -1, but you need everything that is also less than 3, and it has to happen at the same time. So the only time that is greater than -1 and also less than 3 is when it is contained in between there. Now, if it's an or, in this case, like if you were to graph this, here is 0, here's -1, x is less than -1, so everything to the left, less, and then x is greater than 3 would be everything to the right. You would have everything from -infinity to -1, or the union sign, everything from 3 to infinity. So let's practice. We want to solve the inequality. This is an and, so we're looking for when they overlap, when do they connect together. So if I was to solve this left-hand side, the first thing I would do is I would subtract 8, and I would get 2x is greater than -24, and then I would divide by 2, and I would get x is greater than -12. And at the same time, if I was to solve the second one, I would divide by 9, and I would get x is less than 9. So if you were to graph this, sorry about that, I would have -12 over here. Here's -infinity. I would have 9 over here. I need everything that is greater than -12, so I'm going in this direction. But at the same time, I need everything that is less than 9, so I'm going to the left of that. So the answer would be everything that is contained in between. And if you were to write this in interval notation, it would be everything that goes from -12 up to 9. Now this is another and. This is contained between -18 and 15. So in order to solve a problem like this, as opposed to the last one, in this case you would add 6, but you would add 6 to every side. You would get -12 is less than 3x is less than 21. And now when you divide by 3, you need to divide that on all sides. And you would get -4 is less than x is less than 7. If you were to graph it, you'd be going from -4 to 7, open circle because it did not include it, and you have all of the x values that are contained in between there. And if you were to write it as an interval notation, it would be everything from -4 to 7, parentheses and not brackets because it does not include it. Now this is an or, so we're looking for either or. So if I was to divide this by 6, I would get x is less than or equal to 3. Or, in this case, if I subtract 10 on both sides, I would get -5x is less than or equal to 15. And I would divide both sides by -5. And I would get x and -3. However, I divided by a negative, which means I must flip the inequality. If I was to graph this, something interesting happens. X is less than or equal to 3, so it's a closed circle, and we're looking for x is less than. Or, which means this other part could happen, everything starting with -3 and everything past that. So what happens here, that as opposed to an and is basically where do they overlap? Where is it both at the same time? But because this is an or, they overlap, and it could be anything that's less, or it can be anything from -3 and on. So since the entire number line is actually shaded in this case, your answer is all real numbers. I can't write all real numbers. Or you actually can write this as an interval notation. It would be everything from -infinity to infinity. And that concludes solving inequalities and compound inequalities.